Hello and welcome to Science of Mr. Weber. Today we'll be looking at concentration and molarity. So what is molarity? Molarity is just a way of describing concentration, and we do that by describing concentration in terms of moles and liters. So molarity describes concentration as number of moles per liter. Okay, and the unit that we use is moles per liter. We write it out in that format there. So let's have a closer look. So concentration equals number of moles over volume, or C equals N over V. This is an equation you will use time and time again within HSC chemistry. So it's really important that you understand what each of these are. So our concentration in moles per liter is going to be equal to the number of moles of a solute and what volume of solution that they are dissolved in. So let's have a go at a practice question. That's my fish tank there from a couple of years ago. So 300 grams of sodium chloride is dissolved in Mr. Weber's 300 litre fish tank. So calculate the concentration of NaCl in the fish tank to 3 significant figures. Alright, so the thing that we need to find is C. Okay, the other information we've been given is mass, which is 300 grams, and we've also got volume, which is also 300. So what we want to end off with is we want our final equation to look like C equals N over V. So we do not know what N is, but we can calculate that. So the equation that we can use to calculate that is N equals mass over molar mass. So N is going to be equal to 300 grams divided by the molar mass of sodium chloride. Sodium is 22.99 and chlorine is 35.45. So we'll add those together. Gives us 58.44. And this is our equation here, so let's calculate that. That gives us 5.13347. So we're just going to save that number. We're only going to round at the very end. So now we're able to insert our values into our final equation. Okay, so we calculated that number of moles is 5.133. I'm going to save that number still. Our volume was given, and that is 300 liters. So that means our concentration will be 0.017, and there's a few more numbers after that. So to get it to the correct number of significant figures, going back to the question asked for 3, so we're going to go, okay, so concentration equals 0.0171 moles per liter. And that's that question done. So we've got a second question here. Calculate the mass of sodium chloride that should have been added. So Mr. Weber actually needed a concentration of 0.5 moles per liter of sodium chloride. And we need to find out how many grams of salt should have been added. Alright, so the equation that we need to end off with, finally, is we need to find out the mass. So we have N equals mass over molar mass, so we're just going to move that over, and we end up with mass is equal to number of moles times the molar mass. So the molar mass of sodium chloride was calculated as being 58.44 grams, and number of moles we will need to calculate. So the equation that we can use there, N equals CV, or curriculum vitae, however you want to remember this equation, and our concentration was given, Okay, so equals 0.5 times the volume of the tank, which is also given in the last question, times 300, and that will give us number of moles as being 150 moles. Good. So now we can apply that to our equation here. So our final equation will look like m is equal to 150 times 58.44 grams, which gives us a mass of 8,766 grams. Now, because the number of significant figures wasn't specified here, our least significant figure is a 0.5 moles per liter, which is one significant figure. So we actually need to round that to 9,000 grams. Two other measures of concentration that we need to know are looking at things in terms of mass over volume and number of particles. So grams per liter, this is just looking at the mass of solute divided by the volume of the total solution, and that will give you a number that indicates the number of grams of solute dissolved in a liter of solution. Milligrams is very much the same thing here. It's the number of milligrams of solute that are dissolved per liter of solution. Parts per million is where things can get more tricky. So parts per million, or ppm, is a measure of the concentration that indicates how many particles of solute there are in 1 million particles of solution. So if you've got a value of 4 ppm, that means that only 4 particles will be solute within 1 million particles of solution. So this is very effective for looking at solutions of very low concentration. So let's have a go at a question. So we have 150 mils of aqueous sodium chloride, and that contains 0.0045 grams of sodium chloride. So calculate the concentration of NaCl in parts per million. Now, very importantly, 1 part per million is equivalent to 1 milligram per liter, or 1 milligram per kilogram. So what I'm going to do is I'm going to convert to milligrams per liter in order to calculate this. So our mass initially is 0.0045 grams, and we'd like to convert that into milligrams. So we're just going to move our decimal place over 3 spaces. So we're going to end up with 4.5 milligrams, and that's going to be over. So our volume was 150 mils, so we move the decimal place there, and we end up with 0.15 liters. And so our final answer will be 30 milligrams per liter, which is equivalent to 30 parts per million. Excellent. So now getting a bit more specific here, so parts per billion, the exact same concept. So it's going to be the number of particles of solute dissolved in 1 billion particles of solution. So in this example here, so 1 part per billion is equal to 1 microgram per liter, or 1 microgram per kilogram. We will apply this in the exact same way as we did that last question. So let's have a go at this example here. So what mass of nickel is in a 2.4 kilogram sample of propanol if the concentration is 20 parts per billion? So we're going to be working backwards here to find out what our mass is in this 2.4 kilogram sample. So 20 parts per billion is equal to 20 micrograms per kilogram. So what we then need to do is have a look at how many kilograms we have and find out a scale factor. So we've got 2.4 kilograms, so we just need to multiply this number here, our 20, by 2.4, which will give us a final answer of 48 micrograms within that 2.4 kilogram sample. And so that would be our final answer there. Guys, that's all for this lesson on concentration. Thanks for watching. I'll see you next time.